Hello friends, I am Chandan. So here, this is the third lecture of uh, entropy. Okay, so let's try to understand entropy change for system, entropy change for system in case of irreversible process. So in last lecture we just cover the reversible process, but in this lecture we cover the entropy change for the system in case of irreversible process. Okay, so here we know that from first lecture of entropy we know that ds greater than del q by t for irreversible process. So here from this equation you can say that ds that is equal to dq by t irreversible, and there is a entropy delta s, that is entropy generation is there, delta s, that is entropy generation is there. Okay, so this is entropy generation is there. So because ds for irreversible process entropy is less. Okay, so there must be an entropy is there if you want to equate this equation. Okay, so ds that is equal to del q by t for irreversible process plus delta s. What is delta s? Delta s is the entropy generation, and this is always positive. Okay, so this is always positive. Okay, so now consider this is an irreversible heat addition process. Okay, consider first case, that is a irreversible heat addition process. Okay, so this is the heat addition process, but it is a irreversible process. And consider this is system, and in this system this is our irreversible irreversible process is going in this system. Now heat is transfer from surrounding to system. Okay, heat is transferred from surrounding to system. So we know that formula, that is ds that is equal to del q by t for irreversible process plus delta s, and delta s, this value always positive. Remember, entropy generation is always positive. Okay, so entropy, this is entropy generation, so this is always positive. Okay, so as the heat is transferred from the surrounding, so that is why dq for system that is positive, and system temperature is also positive. So from here you can say that, so this is positive value and this is also positive value because dq is a positive value. So from here you can say that ds that is equal to, that is greater than 0. So from here you can say that s2 minus s1 greater than 0. So from here s2 greater than s1, that means the entropy is increasing. Okay, so here entropy, the s2 is greater than s1. So that is why for irreversible heat addition process the entropy always increases. Okay, so hence system entropy increases for irreversible heat addition process. Okay, so that is why the system entropy increases for irreversible heat addition process. Okay, now focus on the irreversible adiabatic process. Okay, so focus on irreversible adiabatic process. So this is our system is there, this is our system. In this system there is no heat transfer through the boundary. Okay, so from here you can say that dq system that is equal to 0, and you know the formula, that is ds that is equal to del q by t irreversible process plus delta s, same formula. Okay, so as dq that is equal to 0, from here you can say that del q by t, this term is 0 and this term is positive. We know that entropy generation is always positive. So from here you can say that ds is greater than 0. So from here you can say that s2 greater than s1. Okay, so entropy change, so entropy is increases. So from here you can say that you can say that the hence system entropy increases by irreversible adiabatic process or non-isentropic process. Okay, non-isentropic process, or you can say that it is a non-isentropic process. So this is an adiabatic process. In last lecture we see that for reversible adiabatic process there is an entropy constant, that is entropy not change. So that is why this is an isentropic process, but here this is an irreversible adiabatic process, so this is known as non-isentropic process. If S2 is equal to S1, then it will be isentropic process. So remember this data, irreversible adiabatic process is non-isentropic process. Remember this is very very important. Irreversible adiabatic process is non-isentropic process. Okay, now there is another process that is considered, this is irreversible heat rejection process. Okay, irreversible heat rejection process. So this is our system. In this system heat is going out from the system. So as heat is going out from the system, so you can say that del Q for system less than 0 and temperature of the system is greater than 0. So we know the formula del ds, that is equal to del Q by d irreversible plus delta S. Delta S, that is entropy generation. Okay, so here as del Q is going out from the system, so this is negative value, this is negative value, so this is negative value, and this is positive value. We know that this is a positive value. Okay, remember that the entropy generation is always positive value, because there is entropy generates is there, because there is no entropy consumption is there, there is entropy generation is there. So this value is always positive. Okay, so ds is, there is a two term, there is one term that is positive term and there is a negative term. Okay, so as there is a positive term and negative term, there is a positive term and negative term. So here consider this is case 1. So case A, consider del Q by T is less than delta S. Okay, so as del A is greater than, so as this is greater than this, this is greater than this, so this value will be positive. So from here, if this condition is satisfied, so ds ds greater than 0, because here see, here this is negative and this is positive, so the whole value will be positive. Okay, so that is why ds greater than 0. So from here you can see that s2 minus s1 that is greater than 0. From here you can say that s2 greater than s1. So if for case 1, if del Q by T less than delta S, then you can say that that is S2 is greater than S1. Okay, so S2 is greater than S1. Now case B, there is a case B is there. In case B here, if del Q by T is greater than delta S, so if this value is the negative value here, if the negative value is greater than this value, so that whole term will be negative. So from here you can say that ds less than 0. From here you can say that s2 minus s1, so sorry, s2 minus s1 less than 0. So from here you can say that s2 less than s1. Okay, so here s2 less than s1. Okay, now case 3. In case 3, if del Q by T that is equal to delta S, then in that case, if it is equal, so this term will be the total term. So here this is equal to this. So positive term is equal to negative term. Okay, as this is positive term is equal to negative term, so this ds value will be 0. So ds value will be 0. So from here you can see that s2 minus s1 that is equal to 0. From here you can see that s2 is equal to s1. That means here the entropy is constant. Okay, so this is, so here entropy is constant, that is why this is this is a isentropic process. Okay, the condition is that the del q by t, sorry, del s by t, that is equal to delta s, that is entropy generation. So in three cases, so here all the things are given in this here. Hence, in case of irreversible heat rejection process, system entropy may increase, may decrease, or may remain constant. Okay, so for irreversible heat rejection process, the system's entropy may increase, may decrease, may constant. So here in case 2, there is entropy is constant is there. In case b, entropy is decrease. In case a, the entropy is increases. Okay, so that is written in this here. Okay, now the second case is that reversible adiabatic process is always isentropic process, but the process need not to be reversible adiabatic process. So isentropic process, so here what is given, the reversible adiabatic process is always isentropic, but isentropic process need not to be reversible adiabatic process, because in irreversible process here we see that there is a heat, there is a entropy constant is there. Okay, so this is an isentropic process, so that is why this term is written here. Okay, now the hence systems in the entropy is the hence system entropy in any process may increase, may decrease, may remain constant. Okay, and entropy change for surrounding may increase, may decrease, or may remain constant. Okay, so remember this data. So entropy change for surrounding may increase, may decrease, or may remain constant. Okay, so this is all about the entropy change for system in case of irreversible process. Okay, so this is my handwritten notes. You can download it from the description link. There is a Telegram group, that is Mechanical Bengali. You can join in this Telegram group. Like, share, subscribe my YouTube channel. Thank you.